So this is 7.3, the very last problem. I'm going to type it in. Did everybody catch? This was another 4 by 5. I hope you put that in to start with. So I went to second matrix, over to edit, told it I had a 4 by 5, and I filled them up. All right, so now I'm going to go back into matrix, over to math, down to RREF, second matrix, A. Okay, now, a couple of things happened. Let's make sure we remember how to handle this. Did you get a bunch of long decimals? Not a whole, I mean a couple of long decimals. So do you remember how we dealt with that yesterday? What did we do?
Turn them into fractions.
That's right. So we go to math, and press just your regular math button, not the matrix math, just the calculator button that says math. And then frac is the first one, so just hit enter, enter. And then that's going to produce the matrix. And doggone it, we lost a row, didn't we? And we lost it completely, which means we're going to have a general solution. Again, we're going to have infinitely many solutions. So this time our variables were A, B, C, D. So that bottom row, we always start at the bottom and work up. So that bottom row literally says D is D. It doesn't tell me anything. So D can be anything. So then this row, read the equation. These are C's, these are D's. So C plus 3/11ths D equals negative 7/11ths. So C equals negative 7/11ths minus 3/11ths D. Now, do I need to slow down? Are you keeping up with that? Does that look like what you're doing? All right, I'll go up one more equation. So this equation says B plus 5D equals 5. So B equals 5 minus 5D. And then I'll go up one more. I'm kind of disorganized here. I'll go up one more. A minus 38/11ths D equals negative 3/11ths. Don't put all those zeros in. There's no B's and C's. It's just A and D. So A equals negative 3/11ths plus 38/11ths D. Now, everybody with me to this point? Now we have to write our answer, okay? I'm going to give myself some room. I'm going to erase all this. My answer, my general form of my answer is going to be A, B, C, D, those are my variables, equal a number plus a D. So every variable will have two components. Let's look at A first. A has negative 3/11ths and 38/11ths D. See how that just really organizes everything? And then D is 5 minus 5D. And C is negative 7/11 minus 3/11. And then what do I do with D again? I'm not going to be confused by that. The number is 0, and there's 1D. That's 1D right there. And that is your general solution, which in many cases is all you want. I mean, your job was to solve the system, that's the solution. But once in a while, you might want a specific solution or a particular solution. So remember, that's easy. You just need to pick a value for D. I told you before, I like to pick 0 for D, because if I pick 0 for D, this is all gone, and this is my specific solution. But if you love to work with fractions, and there is a common denominator, so it wouldn't be the end of the world, pick a different value for D and do that. All right, tell me what questions you have, because we're moving on to something totally different here. So I need to know what questions you have. Was this 7-3? Homework will be due, what's today's Thursday? Next Wednesday. So homework will be due next Wednesday. Anybody have a question or a problem with what I got up here? All good? Okay. Now, we're going to do something that's going to totally knock your socks off. I have been looking forward to this all day, because this is one of the most amazing things ever, I think. We've got a triangle out there, and I'm not even going to take the time to plot it. I'm just going to label, this is the point 1, -1, and this is the point 3, 2, and this is the point -1, 7. Now, if you are one of those kind of anal people that's got to have everything perfect, go ahead, put it on a grid and plot the points. But that isn't going to impact what we're doing at all. But if it makes more sense to you to do it that way, that's fine. I'm going to find the area of this triangle. All right? Now, here's what I'm going to do to get started. Believe it or not, we're going to use a determinant. We're going to use a determinant to find the area of this triangle. So here's what I'd like for you to do. I want you to pick a vertex, and I usually pick A, but it makes no difference. I want you to pick a vertex. And then we're going to talk about the directed distance from point A to each of the other vertices. So I'll start with B. I'm going to talk about the directed distance. So from A to B, and I'm going to use vector notation. We skipped that chapter, so that's a little bit strange for you. But I'm really just talking about, how do I get from point A to point B? And the directed distance is an X movement and a Y movement. So in terms of X's, I'm going from 1 to 3. So think about on a number line. You're going from 1 to 3. Aren't you taking 2 steps in the positive direction? And then -1 to 2. Now be careful. You're starting at -1 and you're going to 2. That would be 3 steps. Does everybody understand that? Think of your number line. If you're at -1, there's 1, 2, 3 steps, right? So the directed distance from point A to point B is 2, 3. 2 steps in the X, 3 steps in the Y. Now, what about from A to C? Do the same thing. From 1 to -1 would be -2. This is a directed distance. So it's got a direction, positive or negative. As you go from 1 to -1, you're backing up basically. And then from -1 to 7 would be 8. Now, is everybody clear on that? Are we okay with that? We all right? So I picked a vertex, and it can be any of them. And then you find the directed distance from that vertex to the other 2. So from A to B, from A to C. Now, take the 2 directed distances, or the 2 little vectors that you just got, and put them in a determinant. So there's the first one, 2, 3, and here's the second one, -2, 8. Now, the order that you put them in doesn't matter. So if you put that one on top, and if you put this one on top and this one on the bottom, you're going to get the same answer. So you write your first directed distance right here, your second directed distance right here, and you're going to evaluate that determinant. So remember, that means multiply, multiply, and subtract. So did you get 22? The area of the triangle is half of the determinant, so it's 11. The area of the triangle, that triangle right there, its area is 11. Now, are you not in awe of the people that figure this stuff out? Because I'm telling you right now that if you found the lengths of all these sides using the distance formula, if you got all these and you did Hero's formula, you'd get 11. And you know how long that would take you? A long time. This is so amazing. One more comment. I told you the order didn't matter. If you had written your vectors in this order, notice your determinant would have come out to be -22. When the determinant turns out negative, you just drop the negative, because obviously area can't be negative. So it would still be 22 over 2, or 11. Ah, that's so exciting. I hope there's another one. Oh, there isn't. Oh, crap. Well, we're going to do another one. Did you have another piece of paper? Or there might be room at the bottom of something somewhere. I don't know. Let's do another one real quick and make sure we know what we're doing. I can't believe I only put one example in here. We're going to do another one. So let's say we have a triangle. And I'm going to use different letters this time just so we get used to that. And let's say point C is -4, 1, and point H is 1, -2, and point S is 3, 7. All right, so let's say those are our vertices, and we're going to find the area of this triangle. Now, pick a vertex, and I'm just more comfortable starting with this one. You can start with any of it, it doesn't matter, but just visually I can see this one better. So I'm going to start with C and go to H. So figure out that directed distance for me and tell me what you get. How many steps, positive or negative, for X and for Y? Tell me what you get. Oh, somebody should have it by now. It shouldn't take us that long to figure out.
Is it 5, -3?
It absolutely is. Thank you so much for being brave. From -4 to +1, it's this way on the number line, so that makes it positive. From 1 to -2 is that way on the number line, so that makes it negative. So that's CH, perfect. Now, what about CS? From C to S. Remember, when you build your vectors, you're building them from the vertex you picked. So from C to H, from C to S. So what do we get?
7, 6.
+7, +6. I agree with that. Does everybody else agree with that? Make a determinant. I'll put 3, 7 up here. Or no, not 3, 7. 7, 6. 7, 6 up here, and 5, -3 down here. Doesn't matter what order you put your vectors. But 7, 6, 5, -3. All right, so what's the value of that determinant? -21 minus 30. Did you get -51? Remember, since this is an area problem, we're going to have to make that positive. So in that regard, these kind of act like absolute values. They're not, but they kind of act that way. So 51 divided by 2. Anytime you're doing the area of a triangle, there's a half involved. 1/2 base times height, 1/2 side, side, sine, semi-perimeter. There's always a half involved. So it's the value of the determinant divided by 2. So that would be the area of the triangle. All right, we got one more thing to learn today. I think we can get it done. It's pretty easy. We're going to do partial fraction decomposition. And this is, for those of you that intend to take a calculus class, this is an important skill. Partial fractions show up in integration all the time when we do integration. All right, so here's how it works. Very, very simple. Step 1. Factor your denominator. Can I do that okay? I almost made a mistake. I think I got it. Okay. Now, there are 2 fractions out there, one of them with a denominator of x plus 3, and one of them with a denominator of x minus 5, that when they got added together, they gave us this denominator. Now, would you agree with that? That if I were to add these 2 fractions, my common denominator of the sum, the answer denominator, would be x plus 3 times x minus 5. Does that make sense to you? Now, I have no idea what these numerators are, so I'm going to call 1a and 1b. So a is over one factor, b is over the other factor. Okay? Now, I'm going to clear the fractions. So I am going to multiply everything in the whole problem by x plus 3, x minus 5. Now, some of you are going to do this in your head, and I am fine with that. But for our first example, I'm going to write down every single step. Now remember, I said I'm going to clear the fractions, because that's exactly what's going to happen. I'm going to have A times x minus 5. I'm going to have B times x plus 3. And then all I'm going to have over here is 5x minus 1. So there are no more fractions in the problem. Are we keeping up? All right. So now I'm going to distribute. So ax minus 5a plus bx plus 3b equals 5x minus 1. Now, I want you to look carefully at the problem and recognize that there are some x terms. There's an ax plus bx equal to a 5x. Would everybody agree with that? So I know that whatever a and b are, they have to add up to 5. A plus b has to be 5. Because these are all x's and they're going to be collected. So these two have to add up to total the 5. And similarly, the ones with no x's, the negative 5a and the 3b, have to add up to be negative 1. Now sometimes that's the step that's tricky. Did you all understand what I just did? All right, what's this? What's going on here? What am I going to do with that?
Substitute or eliminate?
Exactly. And you know me, I'm going to eliminate, so I'm going to multiply the top one by 5. So I have 5a plus 5b equals 25, and negative 5a plus 3b equals negative 1. So 8b equals 24, and b equals 3. And if b equals 3, then a must equal 2. So my partial fractions, a is 2. So 2 over x plus 3 and 3 over x minus 5. And that is the answer to the problem. You guys have done an amazing job today. Thank you so much. You got to admit this was fun though today. I mean, honestly, if you got to end your day this way, what a great way to end it. Right? Okay, listen, I want everybody to have a happy Easter. Everybody good? Everybody okay? All right, have a great Easter. Thanks for coming in. Be safe and smart.
Thank you.
Thank you.
Bye. Okay.